In this tutorial, I'm going to show you how to find the natural frequencies of an hourglass-shaped specimen using modal analysis in Abaqus. This geometry is commonly used in uniaxial fatigue testing, especially in tension compression setups operating at ultrasonic frequencies around 20 kHz. Normally, engineers try to avoid natural frequencies to prevent resonance, but in our case, we actually want the specimen to resonate, specifically in a longitudinal mode that produces a pure tension compression state in the gauge section. Okay, so you can start by creating an axisymmetric part or a 3D part, but for my case, I'm going to import a 3D that I have done in SolidWorks, part, specimen 3D, then I'm going to assign a material to it, and remember the units should be consistent, 4429, but it's in ton per millimeters, so it's E minus 12. Elastic properties, Young's modulus should be in megapascal, and the Poisson ratio. Assign the section, and create the section. Now we assign the section. Assemble the part and mesh it first, then we create a step. So mesh it, what is going on? Part, we want to make it green. It's better for that way. So maybe 3 points. 1, 2, 3, and another 3 points. 1, 2, 3. Fun. If you do wrong, you can go to features and delete. One more try. You go normal to point, and normal to that, and then maybe another 3 points. 1, 2, 3. Let's try for this one. 3 points. 1, 2, 3, and maybe for this one as well. It's already green, but let's stay symmetrical. Okay, so now we mesh it a little bit finer, maybe 1.9. Okay, the mesh looks good. It's maybe too fine for frequency, but it's okay. Now we do the steps. Create a step, frequency step. You can do a range, find the natural frequencies in a minimum and maximum frequency of interest, but for my case I'm going to go for 21st eigenvalues and create a job frequency and submit it. When it is done, you to results, we go to results step frame, and you can see the different mode shapes. You can animate it. We are looking for 20 kHz, so it's this one that we are looking for, tension compression. But you can see the other frequency modes, mode shapes and eigenfrequencies. This is the interesting one. But you can see the 21st frequencies. In the next video, I'm going to apply a displacement amplitude on top of the specimen and vibrate the specimen at its natural frequency. So stay tuned and like the video and subscribe if you learned something. Thank you.